we're here in Santa Clara in the AI Infra Summit, and a lot of discussions here around scalability of AI clusters, AI workloads, etc. And the discussion is usually around scale up versus scale out and scale across, in which scale up is gaining ground with higher and higher scalability, which was always the limit for scale up because it used to be confounded into one server. Now it is bound by a single rack up to 72 GPUs, and in the next generations it will grow up to 576 GPUs across data centers. But still, when you grow past this limit, you need a very robust scale out network. And this is where we come into play. And scale out network is providing basically unlimited scalability, but with the caveat of lesser performance or low performance compared to scale up. And this is where the focus of scale out network is today, making the performance as good as scale up and freeing the workloads and the AI infrastructure from the boundaries of scaling limits across the data center. So scale out network today, in particular, fabric scheduled architectures are very high performance. Actually, they perform even better than InfiniBand, which used to be the benchmark for scale out performance. This is thanks to a scheduled fabric, a VOQ system, and an end-to-end performance guarantee. So basically, you can scale out your infrastructure across the entire data center for tens of thousands of GPUs and still maintain the high performance of the infrastructure required to make your GPUs highly utilized and your workloads perform good in terms of job completion time, in terms of time to first token, and other parameters that you usually measure AI according to. When you are done with the data center, because, for instance, you are out of power or out of rack space, you need to scale across. That means that you want to allow geo-redundancy and add GPUs in other data centers, which could be miles apart from the original data center. This is where scale across networks are built. This is quite a challenge compared to scale out because you need to have a hybrid deep buffer and shallow buffer networking infrastructure in order to allow compensation for the high latency across the inter-data center connectivity. And this is, again, something that has developed in the last year or so, the ability to scale your infrastructure, your GPU infrastructure across multiple data centers, but still look at it logically as a single entity and run a workload across multiple data centers spread out geographically. Again, this is another topic that is heavily discussed in Santa Clara this week. Thank you very much.